So this is the Unit 4 part of the review questions we did in class. So we just started them on Tuesday. We didn't finish. Okay, so some of these you haven't even seen before. Okay, this one is the one we started with because we hadn't done a question like this before. So I wanted to make sure we got this. We did this one. Find the area of the shaded rectangle. So the shaded rectangle is the rectangle in the middle, the smaller rectangle. Okay, we know the area of a rectangle is equal to the length times the width. So we need to find the length and the width of the inside rectangle. We know the length of the outside rectangle is 12 and the width is 18. Okay, we know the gap between the inside and the outside triangle is 2 feet all the way around. So let's consider this length right here. Okay, that whole length is 12. This whole piece is 12. We know that this distance here is 2 feet. And this distance down here is also 2 feet. Okay. Which means our length is 8. Okay. Because if the whole thing's 12 and each of these two pieces is 2, then we need to do 12 minus 2 minus 2, which is 12 minus 4, is going to be 8. So 2 plus 2 plus 2 gives us 12. We're going to do the same thing this one. This whole length is 18. Okay, we know this piece is 2. We know this piece is 2. So our width here is going to be 18 minus 4, which is 14. Okay, if I draw it again, just so it's more clear, we have 2 rectangles, one inside the other. We know this distance is 18. Okay. We know this distance is 2 and this distance is 2. So what piece is missing? It's going to be 14. Okay, so if this is red, right, 14, the whole thing's 18. 2, 14, 2. The whole thing is 18. So 18 minus 4, minus 2 and 2 is going to give us 14. Likewise, we can do this way as well. Oops. Okay, so this piece is 2 and this piece is also 2 from our diagram. If the whole thing is 12, then these 3 pieces need to add together to give us 12. So this piece then has to be 8. Because 2 plus 8 plus 2 gives us 12. So if our length and width are 8 and 14, we do 8 times 14, which is going to give us 112 feet squared. Okay, and that's the area of the shaded rectangle. Next slide, we have find the area of these 2 figures. Okay, so we can split this into a rectangle. Okay, you know this rectangle is actually, it's going to be a square, so it's 10 by 10 and 10 by 10. Okay, so the area of the rectangle is length by width, length times width. So that's 10 times 10, which is going to be 100. We know, so let's see. This whole piece is 10. Okay, so if this piece, this piece here is 6, this piece has to be 4. Okay, because 6 plus 4 is going to give us 10. So since this side is 10 and it's a rectangle, we know that the other side is also 10 units long. So this whole thing is 10. If this piece is 6, this piece has to be 10 minus 6, which is 4. These two pieces have to add together to give us the whole thing, which is 10. Okay. This whole thing is, well, let's see. This whole thing is 16. Okay, this piece we said was 10 because it's a rectangle. Opposite sides of the rectangle are congruent, so they have the same length. So we go up the side here. It's going to have to be 6 because 16 minus 10 gives us 6. 6 plus 10 is 16. Right? These two have to add together to give us the whole thing, which is 16. We know this is 10 because this side's 10 and opposite sides are equal. Opposite sides are equal, so this has to be, whole thing has to be 10, so 10 minus 6 is 4. Area of a triangle is 1/2 the base times the height. So we have 1/2 of 4 times 6, which is going to be 2 times 6, which is 12. Okay. Then we add them together. The area of the triangle is 12. The area of the rectangle is 100. So 100 plus 12 is 112. Next one, we want to find the shaded and unshaded regions. So we know, let's find two areas. We have two rectangles. So the area of the large rectangle is length times width, which is 19 times 7, which is 133. 7 times 20 is 140. 140 minus 7 is 133. The small rectangle, length times width, is 15 by 4, which is 60. If we want to find the area of the unshaded region, okay, that's going to be the small rectangle, the inside rectangle, which is 4 by 15, which was 60 inches squared. You know the area of the large rectangle is 133, so all of this is 133. So all of that is 133. If we want to find these shaded, we have to take the whole thing, which is 133, and we have to subtract what is not shaded. Okay. And when we subtract what is not shaded, we get 133 minus 60. We took away 60, and we get 73 inches squared. Okay. If we add together the unshaded with the shaded, we should get the area of the whole rectangle, which is 133. So 73 plus 60, if we add those together, should give us 133, which is the area of the whole thing. Okay. Next. Okay. That was the. No, we're not going to go over that. That was the question I didn't like. Still don't like it. Probably won't ever like it. I'll be prejudiced against it forever. Right. These we want to name which shape we have. Okay. So 4 right angles and opposite sides are equal. Okay. That's going to give us a rectangle. Okay, we define a rectangle as being a parallelogram with 4 right angles. So opposite sides equal. That's true of all parallelograms. What makes this a rectangle is the 4 right angles. The 4 right angles give us our rectangle. 4 right angles and 4 equal sides. So it doesn't tell us the sides are parallel, but it's going to be a parallelogram. So a parallelogram that has 4 right angles is a rectangle. A parallelogram that has 4 equal sides is a rhombus. So it's both a rhombus and a rectangle. It's going to be a square. So 4 right angles and 4 congruent sides. That's going to be a square. Here we have 2 pairs of parallel sides and opposite sides are equal. That's going to be a parallelogram. A parallelogram with 4 equal sides. So again, 4 right angles is a rectangle. 4 equal sides is a rhombus. Put them together, it's a square. But if it doesn't have right angles, it only has 4 equal sides, it's going to be a rhombus. 2 sides are parallel, or 1 pair of sides. Again, I don't like the wording. I think they should say 1 pair of parallel sides. That's going to be a trapezoid. 2 pairs of adjacent sides of the same length. So here we have 1 pair of adjacent sides that are congruent. And there's a second pair of adjacent sides that are congruent. That's going to be a kite. Okay, and we talked about 7 special quadrilaterals. So the one that's not on here that we talked about was the Isosceles Trapezoid. And that's a trapezoid that's going to have base angles that are congruent. So this is our Isosceles Trapezoid. So you should be able to identify which special quadrilateral it is based on the visual representations. And these are our 7. Here is a chart. So again, this is going over the 7 special quadrilaterals that we have. A quadrilateral is a polygon that has 4 sides. So 4-sided polygon. Okay, 4-sided polygons. We can classify them based on how many pairs of parallel sides they have. So if we have no parallel sides, there's many different types of quadrilaterals that have no pairs of parallel sides. But the only one we talked about were kites. And we can have 1 pair of parallel sides. Which we defined as trapezoids. Trapezoids are quadrilaterals with 1 pair of parallel sides, exactly 1 pair. So let's say exactly 1 pair of parallel sides. The classification we had under trapezoids is if the legs were congruent, or the base angles were congruent. So if the legs are congruent, then it is an isosceles trapezoid. Okay. So these are all quadrilaterals. Isosceles trapezoids are trapezoids. Trapezoids can sometimes be isosceles if the legs are congruent. Okay. Here we have 2 pairs of parallel sides. We call those parallelograms. So 2 pairs parallel sides. We have a parallelogram. Make sure I spell it right. Parallelogram. Okay. If a parallelogram has 4 right angles, so if it has 4 right angles, it's going to be a rectangle. If it has 4 congruent sides, it's going to be a rhombus. Okay. And if it has both 4 right angles and 4 congruent sides, it is going to be a square. So So a square is always going to be a rhombus and a rectangle. A rectangle and a rhombus are always parallelograms. So all three of these are parallelograms, which are all quadrilateral. So all 7 of these are quadrilaterals. Kites are quadrilaterals with no parallel sides, at least the ones we have been talking about. They also have other properties that define them. There's lots of different other ones that have no parallel sides. Okay, exactly 1 pair of parallel sides, we have trapezoids. Okay, under trapezoids, if the legs are congruent, we can have isosceles trapezoids. 2 pairs of parallel sides is a quadrilateral with 2 pairs of parallel sides is a parallelogram. Okay, if all 4 angles are right angles, we have a rectangle. If all 4 sides are congruent, we have a rhombus. So a rectangle is always a parallelogram, and a rhombus is always a parallelogram, but rectangles are only sometimes squares. So it doesn't have to be a square, but a square is both a rectangle and a rhombus. I think that's all in detail as I want to go there. Squares are always rectangles and rhombuses. Rectangles and rhombuses don't have to be a square. Only if the rectangle has 4 congruent sides, then it's a square. If the rhombus has 4 congruent angles, then it's a square. So we could put that in there. So if the rectangle has 4 congruent sides, then the rectangle is a square. If not, then it's not. If the rhombus has 4 right angles, then the rhombus is a square. If the rhombus does not have 4 right angles, then it is not a square. Here we have angles and sides of parallelograms. So we have lots of different properties for each one of these. I think we have them listed at the end here. Okay. So this has all the properties of all of them. We're just going to do 6 problems. So there's a lot more possibilities, but we're just going to do 6. Okay. First one, again, it's parallelogram, so it's not drawn in, but we can assume we have a parallelogram. So 2 pairs of parallel sides. We know opposite angles are congruent. So opposite angles congruent. So we know 9b minus 2 is going to equal 106. Add 2 to both sides. 9b equals 108. Divide by 9. B is going to equal 9 goes into 99 11 times. 99 plus 9 is 108, so this is going to be 12. We know consecutive angles are supplementary. Okay. Again, supplementary meaning that angle measures add up to 180. So these were opposite angles. They were congruent. Set them equal to each other. We got 12. We know consecutive angles, so angles that are right next to each other are supplementary. So 7a minus 3 plus 106 is going to be 180. So this is 7a plus 103 is 180. Subtract 103. We get 7a equals 77. Divide by 7, a is going to be equal to 11. We can substitute in just to see how it works. So 7 times 11 is 77. 77 times 3 minus 3 is 74. Right. 106 and 74 are supplementary. This should also equal 106. 9 times 12 is 108. 108 minus 2 is 106. And then here we would have 74. Opposite sides are So a parallelogram are congruent. So we know 6x minus 7 is going to equal 2x plus 9. We also know that y plus 3 is going to equal 12. Subtract 3, y is going to be equal to 9. Okay, here we can subtract 2x. 4x minus 7 equals 9. Add 7. 4x is going to equal 16. Divide by 4. X is going to be equal to 4. Okay. 6 times 4 minus 7 is going to be 17. 2 times 4 is 8. Plus 9 equals 17. Y is 9. 9 plus 3 equals 12. 12 and 12, 17 and 17. Opposite sides are congruent for parallelograms. Next, we have trapezoids. Trapezoids. One, we have a normal trapezoid or non-isosceles trapezoid, and then we have a trapezoid. So here we have a base, a leg, and a leg. Okay, consecutive angles between bases are supplementary. Okay, that's the property we're going to use. So the measure of angle R plus, so here's our legs, here's our bases, so consecutive angles between the bases. So between the bases, a lot of you guys in the quiz or the test, the quadrilaterals test, you added these two up to 180. Okay, those are not the two angles between the bases. Those are the base angles. Okay, we want to add up these two angles, the angles between the bases. So we want to do measure of angle R plus 78 equals 180. Subtract 78. The measure of angle R is 102. So measure of angle T plus 132 equals 180. The consecutive angles between the bases are supplementary. So here's the bases, here's the angles between the bases. Subtract 132. The measure of angle T is 48. If we add all of these up, they should equal 360. So 180, 180, 360. Okay, next one we have base angles that are congruent. So this is going to be isosceles trapezoid. So we know a little bit more about isosceles trapezoids. There's a few more properties. For example, the base angles are congruent, okay, which will help us. Okay, but let's solve it the first way. So we know consecutive angles between the bases are supplementary, right? This applies for trapezoids, and isosceles trapezoid is a trapezoid. Okay, isosceles trapezoid is a trapezoid. So all the properties still apply. So consecutive angles between the bases are supplementary. So 10x plus 10x plus 20 equals 180. 20x plus 20 is 180. Let me do it somewhere else. Let me erase all this. Okay. 10x plus 10x plus 20 equals 180. 20x plus 20 equals 180. Subtract 20. 20x equals 160. Divide by 20. X is going to be equal to 8. So we can substitute that in. 10 times 8 equals 80. So the measure of angle B is 80. 10 times 8 plus 20 is going to be 100. So the measure of angle A is 100. We know in an isosceles triangle, the base angles are congruent. So if this is 80, this one is also 80. So angle C is going to be 80 because those are the base angles. Then angle D is going to be 100. Because again, the base angles are 100. So you don't want to make the mistake here. This is not isosceles, so these base angles are not the same. This is 48. Right, this is 48. This is 78. They're not the same. But since this is isosceles, your base angles are the same. 100 and 100, 80 and 80. Make sure it's, before you solve, and you want to do that, make sure it's isosceles before you say the base angles are congruent. All right, last two problems here. We have a rectangle and a rhombus. Okay. We have a rectangle and a rhombus. In a rectangle, okay, we know diagonals are congruent. So our diagonals DB is congruent to AC. So AC is congruent to BD. So AC is equal to BD. AC is 9x plus 20. BD is 10x plus 8. Subtract 9x. 20 is going to equal x plus 8. Subtract 8. 12 equals x. 9 times 12 is 108. Plus 20 is 128. 10 times 12 is 120. Plus 8 is 120. The diagonals are congruent. Okay. In a rhombus, okay, we know all sides are equal. Okay, so all 4 sides are congruent. Okay, all 4 sides are congruent. So we know x plus 14 is going to equal 5x minus 2. Subtract x from both sides. 14 equals 4x minus 2. Add 2 to both sides and then divide by 4. 16 equals 4x. Divide by 4. X equals 4. Okay, if we substitute it back in, 5 times 4 is 20. Minus 2 is 18. So all the other sides should also be 18. 4 plus 14 is 18. Okay. We can also set up the equation 2y plus 4 equals 3y minus 3. Subtract 2y. 4 equals y minus 3. Add 3. 7 equals y. 3 times 7 minus 3 is 21 minus 3, which is 18. 2 times 7 plus 4 is 14 plus 4, which is 18. So all the sides are congruent. All sides are 18. So that's what the problem's last slide I have for you. I don't know if you guys can read that, but you can certainly pull up the link. If you guys want to see this, it has all the properties listed out for our quadrilaterals, our 7 special quadrilaterals. You have it all in the reference sheet. This is just another version to look at if you want. Okay. So that is the end of the in-class review questions. Should be about 2 hours total going through all of them. Then you have about 2 hours total for the study guide. So you have 4 hours of videos. Again, don't watch the whole thing. Just pick the parts you need and the parts you don't understand. Good luck on the